Cosmologist Brian Keating is a professor of physics at UC San Diego. He is the host of the podcast Into the Impossible. Today we'll discuss physics, aliens, and his 2 books. Please like and subscribe, and I hope you enjoy our conversation. Brian, thank you so much for coming on.
It's a great pleasure finally to meet a fellow brown bear, Carlos. Nice to have you.
Yes, that's right. Ever true. Class 2009 over here.
That's right.
Yes. Yeah, you were from the 90s.
That's right.
90s cohort. So many just esteemed alumni. It's a great place. Wonderful institution. So I've recorded an intro for you so people have some context about yourself. And I'm sure many folks in my audience will be familiar with your work, your excellent podcast and YouTube channel. Your audience aligns a lot with my audience, actually. The top alignment is Curt Jaimungal, who I know you're familiar with. I believe you're friends with as well. I interviewed him a few weeks ago, and yours is up there too. It's like top 5 all the time.
Oh.
So so it's a good meeting, I think, of the audiences. And we're going to talk about as much as we could possibly cover today. But I do want to start off with, we're going to cover your 2 great books I have right here, Losing the Nobel Prize, your more recent book, Into the Impossible. And if you wouldn't mind, I'd love to start off with Losing the Nobel Prize. And what a wonderful narrative you have here. I really enjoyed your writing style. I'm quite a stickler, actually, for books. I don't finish most books that I read, but I enjoyed your conversational style and your openness that you had with the book. And one of the things I really admired, I think, was just how you were open about how much you sought after the Nobel Prize. And I commend you for that, because I think few people and few scientists would openly confess this desire for external validation, right?
Yeah.
Though I assume many share yours as well. Would you say most of your colleagues share in your obsession?
I think it's not as overt as it was for me. I think I was, much more kind of blatantly aspiring to it, primarily because of a deep-seated, confrontation and competition with my late father, who was a great scientist, but who abandoned me and my older brother at a very young age and left us on our own. My mother raised us as a single mother in very lower middle class New York State. And I always kind of resented that, and that he chose science over fatherhood. And he didn't really have to, but he had a great career as a scientist, as a mathematician, as a quantum physicist as well, theorist, and was a brilliant person, but he just was not a good father. And instead of competing with your father figure, by who could throw a farther football or, wrestling, as I do with my kids now, but in a friendly way, I kind of had an unhealthy obsession with besting him and showing him, what he had abandoned, and making him kind of regret and be jealous of my accomplishments. And so it's kind of a base, not the most, elevated, auspicious way to kind of motivate a career. It was kind of a chip on my shoulder that I had for many years. But I knew I could do him many millions of times better if I won the Nobel Prize, and kind of showed him that I had kind of the dominant hand. And so, concomitant with the actual competition with him came a genuine curiosity and deep-seated desire to understand the universe in a way no one had ever done before, which is to glimpse the very first, nanoseconds of the origin story, if it indeed occurred with a singular origin in a Big Bang, called inflation. And I invented a telescope called BICEP, which would later go on to make the first claims that we had detected what are called waves of gravity, gravitational radiation, plus the concomitant explosive origin of the universe known as inflation. And immediately we were all whispered in the terms that couldn't be any higher of being Nobel worthy. And it was sort of back to my days at Brown and before, when I really thought about doing these types of small projects with huge impact, high risk, extremely high reward. And everybody told me, even when I got offered a position here at UC San Diego, I was told that, I only got the job because the rest of the faculty thought I had a good chance of winning a Nobel Prize. And I came with a pedigree, and I came with, backing from Caltech and Stanford and Brown. So, the elite of the elite. And, still the thought was, I'm only as good as my ideas. And so to come up with an idea that was Nobel worthy, to attempt to, to make myself, retroactively worthy of, besting my father, but also satisfying this deep curiosity about the origin of the universe. That was my motivating factor.
Mm, yeah. And it comes through in the book. I mean, you're so open about it. And one of the things I love is just how, and you've talked about this on your podcast, maybe with Joe Rogan as well, the how wonderful your stepfather was and how welcoming his family was to you. And I loved reading that and seeing that, and it's like, oh wow, at least you had that father figure in your life for that period.
Yeah.
So the focus on the book, there's a few different things you focus on there, but of course the Bicep 2 telescope, and just for folks who don't, I wrote it down. It's aimed to detect primordial gravitational waves. And it's funny because I believe it was 2014 when y'all published your results, and I was under the impression that cosmic inflation was pretty well accepted, that it didn't need any more verification. I was like, oh wow, I had no idea so recently, something that I took for granted as being pretty true. So could you help the audience? I mean, inflation, correct me if I'm wrong, it's the period between 10 to the minus 32 seconds and 10 to the minus 36 seconds, somewhere in that range, after the Big Bang. What's so special about this period?
So inflation, really puts the bang in the Big Bang. It explains why the universe was expanding from its earliest moments and not contracting or being stationary. And it explains the origin of structure in the universe. How did galaxies and clusters of galaxies get there? It explains the quantum nature of the existence of the universe's most largest structures in the entire universe, and it also explains why the universe has these peculiar features that are highly unlikely. We say that the universe is flat, meaning any triangle you make, no matter how big or how small, you could make it off the surface of the Earth or off a curved surface. But any three stars in the universe, any three galaxies in the universe, any three clusters of galaxies in the universe, and any three spots on the microwave background, or two spots on the microwave background, they all, when you make a triangle, they all have interior angles summing up to 180 degrees. So we say that they have flat curvature, just like Euclidean geometry would suggest. But 0 is a special number. 0 curvature is very unexpected. And for the reason that you could have an infinite number of positively curved spherical geometries, there's an infinite number of real numbers between 0 and infinity. And there's also an infinite number of negative curvature values from 0 to minus infinity, if you like. So out of the dual infinity possibility space, out of negative infinity to positive infinity, our universe chose or was forced to occupy one particular value. That's the least probable state. If you chose another number, pi, it would also be incredibly improbable. So the question had to beg an answer, which is what caused the universe to have this highly improbable value for its curvature? And so along with some other peculiar features about the observed universe, such as the so-called horizon problem, which means that any two spots in the universe have exactly the same temperature to be within a few parts in a million, and these spots may have been separated by billions of years in terms of their their subsequent evolution. And finally, there's a absence of objects, exotic objects called magnetic monopoles. We don't observe them. They're generically expected to be very populous, rivaling the abundance of other exotic particles and nuclei. We don't see any of them. Mm-hmm. So all these things, it turned out, could be subsumed and synoptically included in one master theory, which is what scientists aim to do. We don't aim to, prove, every single physical fact about the known universe. We can't prove any physical facts about the known universe. It's not a mathematically, certifiable type of proof. We can only exclude and prove things wrong. So, but when you have a high explanatory power, as does this theory of inflation, people come to believe that anything that it predicts will be correct. But there are other theories that predict the exact same observed data, that the universe would be flat, the universe should have this horizon problem solved, and, for example, there should be no magnetic monopoles. And they also do that. So the question is, what is the unique, falsifiable signature of these different models to exclude them and prove them wrong and leave other remaining to be a candidate model for the true origin of the universe, or at least a more accurate and precise origin of the universe than what we had before, which was just a hot Big Bang. So it's a long way of saying we did not know for sure that the universe originated in an inflationary type singularity, and we still don't, because 10 years ago exactly, when this episode is out, on March 17th, 2014, we announced that we had detected this inflationary, pattern, and headlines around the world said, shoe in for the Nobel Prize. But even more than that, than appearing on CNN and the New York Times and the San Diego Union Tribune and the Brown Daily Herald or whatever, was this spectacular realization, as Alan Guth would say, that the real, perhaps true description of our universe was not a lone, single universe, but in fact, it came along, part and parcel with inflation, that we lived in a multiverse. So on that day, we had people from Max Tegmark to Lawrence Krauss and many other people in between, Sean Carroll, really saying, if these results are confirmed, spoiler alert, my book is called Losing the Nobel Prize, so they weren't confirmed. And the reason why I describe in the book is a mixture of culture, memoir, and scientific greed. And so how do we actually come about this? Well, we have a theory of inflation that comes hand in hand with a theory of the multiverse. So the stakes really couldn't be higher in terms of what the announcement would have meant if it had been borne out. But I like to point out, it's not like we made a blunder, like we had this telescope and, I just had my thumb on the, my finger in front of the viewfinder, and I made a big mistake. No, we saw the signals that we saw. They're more accurately measured than ever. But what we were seeing was not this imprimatur, this signature of inflation and gravitational radiation, but instead were microscopic versions of these meteorites called dust in our galaxy. And I should add, for your audience, predominantly, I'm sure, maybe the second most brilliant audience in the known universe. But I love to give away these meteorites to people from the educational and scientific community. So if you go to briankeating.com/edu, maybe you'll put a link in the show notes. I will send you one of these meteorites, including you, Carl.
Oh my gosh.
So that's the way I love to do. And if you don't have a .edu email address, just go to briankeating.com and you can sign up, and I may send you one anyway. So.
Oh, wow. That's awesome. Thank you so much. And I will, just for our folks listening and watching, I'll have everything in the description of the show notes. So links to your books, links to your website, your socials, everything. So people can, your YouTube channel as well, of course. So, very cool. And I wish, if I may say one thing, I'd love to hear more from, and you do them quite regularly because you're growing so fast, but I really love your AMAs.
Oh,
yeah. I think I love just hearing you go for it and talk for, 45 minutes, an hour, etc. So I'd love to hear more of those. And I make a deal with my audience every 50,000 subscribers. I do an AMA and kind of giving back, and they're slightly getting closer together in time, which is a good sign. So that's good.
Glad to hear that. I'm definitely in the plan, and the goal for 2024 is hit 300,000 subscribers is sort of my internal goal. But maybe we can do it, maybe not.
Awesome.
With your help, maybe your audience will push us over the top.
Yeah, keep you growing. That'd be awesome. So where are we right now? So I guess in the last 10 years or so, what kind of progress has been made with cosmic inflation? Does it seem more likely to be true? Is there less evidence? Like where has it moved the needle?
Yeah, it's actually gotten more and more precise. We've measured the cosmic microwave background. And what we have now, when I should say the team that's doing the most work on this is the BICEP team, but I'm no longer a part of it because I've become a leader of another experiment called the Simons Observatory. And since my book came out, which is very critical of the leadership of the BICEP-2 experiment that I had formerly led, but then, had been removed from prior to this announcement, which meant, for many reasons, I couldn't win the Nobel Prize, perhaps. But the BICEP team has now gone on to the fourth generation. So I created BICEP-1, became BICEP-2. I played a big role in that. And then BICEP-3 I was not involved with. And now instead of calling it BICEP-4, it's called BICEP Array. which is an array of 4 telescopes, each one a refracting telescope like this one, just like the type Galileo invented, except using superconducting detectors operating near absolute zero that Galileo could never imagine. But the instrument goes on, has made the most spectacular upper limits, but no detections yet. So there's no measurement of what would be the equivalent of slam dunk, smoking gun evidence that inflation took place. Can never say it was proved. We can't prove that the Big Bang even happened. We can't even say for sure what the nature of the Big Bang was. Was it the beginning of time? Was it the beginning of the creation of matter? Was it the existence of a new observable universe from a collapsing, pre-existing universe, a cyclical cosmos? These are all open possibilities. So we never prove that there was a singularity, but you can motivate the types of behavior that come part and parcel with each one of those theories. But with inflation is the only theory that predicts there would be these waves of gravity. So what is a wave of gravity? So I can make a wave of gravity right now, shaking my fist back and forth. Anything that has mass that's accelerating will create waves of gravity. Famously in 2015, three leaders of the LIGO experiment and their team detected gravitational waves from black holes colliding together. So those are one solar mass objects, basically, 30 solar mass objects coming together and releasing the equivalent, forming the equivalent of a 59 solar mass black hole. But then 1 solar mass worth of mass energy was converted into shaking up the fabric of space and time. And those are called gravitational waves. So that's another manifestation of it. So they did win the Nobel Prize, and I've interviewed all 3 of them and written a book with one of the 3 winners as writing the foreword, Barry Barish, called Think Like a Nobel Prize Winner. And these reverberations in space-time are uniquely predicted to be cosmological, meaning it's a background, just like the CMB comes in all directions, in all seasons, all times of day and night, no matter where you are in the universe. So too would inflation, because it's earlier, would also produce a background radiation field, but it wouldn't be visible light. It would be waves of gravity traveling at the speed of light since 10 to the minus 36 seconds after the Big Bang. So it still wouldn't be time equals 0. That's impossible. But it would be as close as human-made devices could ever approach this origin state. Now, again, anything in science is not universally accepted. There are contenders. There are people that find the multiverse in particular completely anathema to the way science should be done. And I find it really fun to explore those consequences of their models, alternative models, but also, to keep a gut check in place that forces us to be honest with what we're doing. We're not making up data. We're not doing, crazy tricks or p-hacking or doing things like that. But there's a tendency, like we had in 2014, to see what we wanted to see and kind of discard evidence to the contrary, perhaps, or play a little bit loose with the data that were available from a competitor called Planck. So in all these ways, I think we in the Simons Observatory and they on the BICEP array team have made huge strides in the technical details of the measurement. And it's almost as if the sociological implications of or components of these collaborations may be at some level almost as equal an impediment as the cosmic dust that we saw with BICEP 2.
Okay, interesting. I want to ask you a few questions too about the Nobel Prize, which is a big focus of the book, of course. And you have some criticisms around the process that people could. I do want to leave some stuff for the book for people, not all the spoilers to get out.
Yeah,
but I have a couple questions. One thing I did not know going in was that the Nobel Prize cannot be given posthumously.
Yes.
Posthumously, I should say. So, which seems preposterous to me. That seems like, oh my God, why is this not allowed? Why is this not permitted? Is there a reason behind that? Like, what is the logic that they've given around that?
Well, I think that there's a kind of a reason, and then there's like the real reason. I think partially they want to keep it a very select cohort of people. And because of that, they want to restrict it as much as possible to, the fewest number of people, perhaps that could be, successfully achieving it. Because, it's supply and demand. The more people that win it, the less kind of prestigious it is. And so the most of the motivation for them has been to do things in the past, either retroactively change the rules, or deny the rules that Alfred Nobel had put out in the first place, including things like you was restricted to one person, which in some sense should make them even more happy. But there's sort of a happy medium between giving it to nobody and giving it to 1,000 people. And every laureate that I've talked to, 19 Nobel Prize winners, and every single one says, "Oh no, they should give it to they should give posthumous awards, and they should give it to more than 3 people." But I point out to each one of them, none of them have ever returned their Nobel Prize or refused to accept it. So this law against posthumous prizes was enacted in 1974, and actually it's been violated too. The scary thing about the Nobel committee, it's kind of like what they used to say about the Soviet Union in the old days, before your time. But they used to say, in the Soviet Union, the future is known, but the past is always changing. And so they would make up new rules, like even innocuous ones, like Alfred Nobel said, I want to endow, 5 prizes in, physics, chemistry, biology or physiology, peace, and literature. And then I want to do that for the betterment of all mankind. So 2 or 3 years ago, they then changed it. They changed what he said in his will to say for all humankind, to be politically correct. It's just a narcissistic, idiotic kind of thing. You're going to be politically correct. Like anybody thinks that no women could win it. I mean, there haven't been that many women who have won the physics Nobel Prize. That's true. But to say that, like, if you say mankind, which was universally accepted to be all encompassing of the entirety of Homo sapiens on Earth, that somehow that would be politically incorrect. So it's just kind of ridiculous. And so, I think that there's reason to make updates to it, but I do also say that in the book that it's at risk of basically, not having a popularity that it once had, as many other prizes have come to be. So the question is how do you actually can maintain the prestige and the honor and the kind of motivating factor that people like me would have in it, but take away kind of the mercurial and really opaque rules and so forth that prevent it from being transparent to the world. And so when I nominated the winners in 2016, I guess it was, I was told that my nomination would be kept secret for 50 years, which is longer than the Kennedy assassination files have been kept sealed. So what do you do with that? Like, why does it need to be so secretive? And in some sense, it's the most valuable monopoly on Earth because it has the fewest number of living, people. It's much more prestigious than the, what else is there? The Grammys, the Oscars. You give it to presidents, and they're kind of embarrassed about it. So it's the highest accolade that society has to offer, and yet we don't do a great job at making sure that it's really a representative of the way that science is done today, which is not by lone or 3 geniuses working together. It's huge teams working for decades. And it's time to also not, kind of reject what the founding father, the patron saint, Alfred Nobel really wanted.
Yeah, absolutely. Now, despite those shortcomings, I do have 2 opinion questions for you about the Nobel Prize. One, do you have a most underrated Nobel Prize winner, someone who's been kind of lost to history?
Oh, that's a really good question. There's a lot of people that should have won the Nobel Prize that didn't. And so, I definitely would add hundreds of, tens of people to that, not just the many people on an experiment. But I would say there's also been a lot of confusion that gets reified by the Nobel Prize. So, for example, one of my professors in Europe, maybe, I don't know if you ever heard of him or met him, but Jerry Guralnick, he was really one of the primary drivers behind what's called the Higgs boson. But because of publicity and so forth, no one will ever know his name. He passed away, sadly, about 7 years ago. But he will never be known because it's called the Higgs boson, and Peter Higgs won the Nobel Prize. And so that kind of solidifies, and we often teach it in certain ways. Here's an experiment, it was done by Millikan. Millikan won the Nobel Prize. Or here's the Michelson-Morley experiment. And they did it in 1896, and they won the Nobel. So, it kind of has this rewriting of history effect. So that makes it a little dangerous. In terms of Nobel Prizes that have been won, and kind of are underappreciated. That I would say would fall into two different categories. There are prizes that were not appreciated in their time, but have come to be appreciated. And then there are things that people appreciate but don't really understand why, or what the technical challenges were of doing it. And I would say that some of the things that get lost to history are things like when the Nobel Prize for the discovery of the cosmic microwave background occurred, there was another Russian scientist, I think it was Kapitsa, I can't remember exactly who actually won half the Nobel Prize money at that time, as opposed to Penzias and Wilson. So like his achievements were overshadowed by the people that the Nobel Committee didn't think were really as deserving, which is kind of a curious way to do it. I think that the some of the discoveries of in astronomy in particular, the discovery of dark energy is really not appreciated, and kind of the implications that has for all of humanity and what's going to happen in the deep future of the universe, kind of existentially going to occur. So yeah, I would say that one in particular is sort of underappreciated. It took a long time, before it was awarded, and there are still Nobel Prizes to come, hopefully. But again, it's awkward for me because I write really kind of this Jeremiad against the way that it's being implemented and the purposes for it, but I don't want to ever criticize the people who won it, because one of the only rules they adhere to is you can't nominate yourself. You have to be nominated by other people. So in that case, it's sort of interesting. How do you how do you criticize something gently without actually criticizing the people who won it, because it's really not their fault in a real sense.
Oh, sure. Yeah, absolutely. I'm so glad you just mentioned something I was going to ask you about, the dark energy. So I was having lunch with a friend this week, and I mentioned I was going to interview you, and we're eating some pizza, and he's like, you know what? What the heck is dark energy, man? It's just like, you have to ask this guy, because dark energy plus dark matter, I believe it comprises, we think, more than 90% of the stuff in the universe. Is that right?
No, it comprises about 70% of the universe's energy and mass budget. So yeah, the total amount of energy and mass with our interconvertible, thanks to Albert Einstein over here, E equals mc squared. But their dark energy is not material, or so we don't believe it is. But it's almost as mysterious as any other, as the greatest mysteries of human existence.
Gotcha. So what do we? I know it's an open question, but what are some of the leading theories around what it is?
Yeah, so those are incredible questions. There are questions as to whether or not it's what's called a cosmological constant, and that would mean that the universe is destined to accelerate in its expansion forever, and that it will expand over time and get faster and faster, for part of its expansion. Eventually, perhaps ripping apart every single thing in the universe will be expanded from everything else, including the bonds and the chemical elements in your body. And so that would be, that would be pretty awkward, right? So, from the sense that we, like to think that we understand the universe, that presents a huge challenge to our concept of existence. Also, this energy of empty space, is such a bizarre concept, but it actually is very intimately related to the inflationary universe that I study, which is this tremendous blast of explosive energy, if you will, for an incredibly short amount of time, equal to, as I said, a nanosecond or less. So during that time, the same type of energetic expansion occurs at a much, much faster rate than we're experiencing now. Now we have objects that are receding away from us at, fraction of the speed of light. But in the extreme early universe, if inflation is true, they were expanding away from each other faster than the speed of light, which is just mind-boggling to think about. So they're related to each other, but they're equally mysterious in a certain way. They're completely distinct in terms of their ramifications. Observationally, we see dark energy primarily through what it does to galaxies and clusters of galaxies, and how they're were much more tightly packed in the past, and now they're getting more and more diffuse, and that means they're accelerating at a faster rate. We've known the universe expanding for over 100 years, about 100 years. But we didn't know it was expanding with a time derivative until 1997, 1998. So the short answer is we don't have no idea what it is. Some people say it's a type of vacuum energy, energy maintained inside of the vacuum itself, related to all sorts of bizarre things like the notion of producing pairs of particles out of the vacuum, which is also in a way related to something called Hawking radiation. Other people think it could be a type of energy that's slowly changing with time. And so it's not a constant, it's evolving. And that would have implications as well. That mean perhaps the universe could collapse again. The dark energy would lose now it's the dominant energy, as I said, 70% of the energy in the universe. But in 100 billion years, it could lose its punch, and the ordinary matter and dark matter in the universe would sort of take over again. And it happened in the past, and it could happen again if the dark energy decays. So if it's not a constant of nature. And so these are equally interesting things that we're trying to study with telescopes like the Simons Observatory and optical observatories like the Vera Rubin Observatory.
Okay, fascinating. Thank you for that. I want to give you like a little hypothetical, if you don't mind, or like a little thought experiment. So there's many competing theories of everything out there. I'm sure you're familiar with many of them. Are you familiar with the game roulette? I don't know if you gamble at all, but Vegas.
Yes, I do know about
yeah,
roulette.
Yeah. You gotta put bets on, and you can put multiple bets on the table, right?
Right.
So let's say you had a roulette table with theories of everything all laid out, all along the table, right? So and I give you $100, right? And you can spread out that however you want. You can put a little bet here, a little bet there. If you feel really confident, maybe all of it on one. How would you spread it around right now if you had to?
That's an interesting question. I wouldn't spread it around in terms of like, should we think about, let me say it like this. I wouldn't spread it around and say that I think each are equally likely. I would instead spread around the money or attention to produce more and more experimental results. And the problem is that the energies that the strings, in string theory might exist at, or the energy that that you might find a hypothetical the version of what's called loop quantum gravity, these unification schemes, they are usually at energy scales far above what we can test in the Large Hadron Collider. So that makes it very awkward because you have predictions that can't be tested. Instead, I would say let's use the biggest particle accelerator ever made, namely the universe, and look downstream of the features that should be present in a universe that, say, where string theory dominates, or with the loop quantum gravity dominates, or my friend Eric Weinstein's geometric unity, might be true. It has observational predictions that can never be tested on Earth. It can never be tested in an accelerator the size of our solar system, which is completely impractical. But it could be tested using the cosmic microwave background and the subsequent evolution of the universe since the time the universe was an infant. So we probe everything in the universe's history from its origin till today by virtue of these artifacts, these fossil relics of the early universe called gravitational waves, if they exist. But we don't know that they exist yet. So I would say there's too much effort put on these theories. There's no kind of Rosetta Stone that translates between those. Stephen Wolfram has an idea, and Eric Weinstein, and then Edward Witten, and et cetera. But nobody really has taken the time to look at somebody else's theory of everything and ask, well, it might be mathematically elegant, but what are the observational predictions? So I would kind of like, bet on, what is it, green? There's two green square, slots on the roulette wheel, like 0 and 00. I would just kind of cop out and do that, unless you say you're going to bet, you're going to include these fundamental, what Karl Popper called, decisive experiments. And the most decisive ones will have to involve the early universe. There's no, kind of hope that these things can be tested on kind of the tabletop or even, CERN scales. They have to be tested in the size scale of the early universe.
Gotcha. Okay, thank you so much for that. I also wanted to ask a quick question about, I know it's a little bit of a tangent, but is it a podcast if we don't talk about aliens? I don't know if
that's right.
counts.
Aliens or Bitcoin, Carlos. It's a law. You have to.
Like, yeah, right.
I've never aliens. Yeah.
I know nothing about Bitcoins. That's funny. So I've heard you say on a couple podcasts before, and I imagine it's probably you have the same position now, there's almost no chance of intelligent aliens. I actually published a video a few months back covering the Fermi paradox, and specifically a paper by Sandberg, Drexler, and Ord, that they estimated that there was a 39 to 85% chance that we're alone in the entire universe.
Yeah.
Using a range of observations, stuff like that. So it's, they say it's pretty unlikely.
Yeah.
But I did get a so I'm sort of aligned with your thoughts around it, I think. But I did get a comment on my video that I couldn't answer, and it was like, "What about us? Like, there's an N of just one. Like, how did we come to be if there's just one of us, right?" And I have a hard time coming up with a response to that. What do you say to that kind of a retort?
Well, I actually think it's, there's no reason not to think it's just us. If you look at all sorts of different kind of cop-outs and rascals and scoundrels that will appeal to things, and that includes people like the late Steven Weinberg. I shouldn't criticize the dead, but that the anthropic principle and even things that denied the Big Bang he was supportive of, because they didn't resemble, say, the existence of God. And yet all these things do kind of put, they either, portray the human existence as extremely common or likely and nothing special, say, or they'll say that, of course you would expect to find ourselves in a universe out of a multiverse of an infinite number of other universes. So it's kind of this appeal to popularity, not popularity in terms of who's, but sheer number statistics. So it's a cognitive bias that suggests that, because there's a large possibility, that there's a large probability. And the way I always refute this is saying I've been to Antarctica twice. And when I was there, there were only like 300 other mammals there, and they were all, on the coast of Antarctica. There's a couple more, whales and sea lions, but that's about it. And so if you just said, well, Antarctica is 1/7, there's 7 continents on the Earth, and then you would assume each one should have the same number of people, and yet one has 10 to the minus 9, to good approximation, the population of the other 6. So that would be kind of strange if you grew up there. You might say, oh, well, of course we're the only life on Earth, literally, and you'd be wrong, but that's not an incorrect assumption to make. On the other hand, extrapolating from the other 6 continents and saying there must be, the same number of people living in Antarctica, you'd be wrong by a factor of 1 billion. So the question is there, just by the mere number and quantity of this number of stars, planets that have been discovered around other stars by the Kepler satellite and other teams, but I kind of like to invert it and say this probability that you mentioned of 30%, is that right now? Because in other words, a lot of these galaxies and is it for the whole universe, or is it from our galaxy? Because we've ruled out a very large region of space. Okay, yes, the galaxy is quite large, but we can observe it for, the galaxy is a few 100,000 light years across. We happen to be about 100,000 years old as a species, and if another species that happens to be much farther away than than the age of the universe, or the age of our galaxy, or the size of our galaxy times the speed of light, then that would mean that we should have some evidence for their existence, and yet we never picked up any sign of evidence. We haven't even seen evidence of truly life, or the substances produced by life. And so for me, I never say never. I think that there's probably life out there, but I like to turn it around and say, if you looked at if you were an alien and you looked at the Earth and Mars, you would say, here's a habitable planet, or here, the Earth, Mars, and the Moon. I mean, they're basically like 3 planets, and there's life on one of them, and there's no life on the other 2, and there's no life anywhere else in the solar system. And yet we know for sure that there's people on podcasts on one of them. So that's very odd that you shouldn't even find like scraps of life that evolved on Mars 1 billion years ago, when the Earth had early primitive life. And these meteorites, like the ones I give away in my website, that they were impacting the Earth and kicking out material that had life, DNA, tardigrades, whatever. They were impacting Mars, and yet nothing ever took hold on Mars, as far as we can tell. And that's the closest, most hospitable place in the solar system. The Moon has almost no chance for ever having life. And so you look at all these things, And the other thing I like to point out is that you and I are only talking because there were 3 enormous collisions in the Earth's history, at least 3, that were Goldilocks collisions. They were collisions that had the following properties. The collision that formed from a proto-Earth called Theia, some object hit the Earth, this giant Earth, and cleaved it into the Earth and the Moon at just the right time, such that the Moon would eventually form over hundreds of millions of years and then would produce things like tides on the Earth's oceans. Oh, but wait, how did the Earth get water? Well, it needed to be bombarded by comets carrying ice that then hit the Earth and formed the liquid ocean. And then maybe some of those comets had amino acids or whatever was hypothesized. And then those evolved to make more complex forms of life. Okay, so that's one. And then we had to beat out the dinosaurs because they were annihilated by the impact crater that caused the Chicxulub, or the impactor that caused the Chicxulub crater in the Yucatan Peninsula. So, but that couldn't have been too big because that would have wiped out all life, including the little tiny rats that you and I, evolved from, or whatever. We have some common ancestor. I'm not calling you a rat. Sure. I'm more a rat.
No.
So, but you know what I'm saying? The interesting fact is that we suffered 3 major, incredible impacts that happened to be just right in both the size of the impactor, the type of material delivered by that impactor. In other words, if the comet extinguished crashed into the Earth, it wouldn't have produced the Moon in the same way that this body the size of Mars that became the Earth-Moon system. And then, by the way, the Earth and the Moon have to be just the right distance away from each other, and the Moon has to be able to catch some asteroids that would otherwise impact the Earth. So you look at all these things, and then you look at the planet Jupiter, which also protects us. The Earth has a magnetic field. We come up with a very low probability of life, but all the more so for intelligent life. You think about consciousness, you think about technology, opposable thumbs, you think about all the ways that things could have gone sideways, and that we're the only, again, you can say that I think there's a billion different types of species. There's only one species that's conscious as we know it. It's incredible. The fine tuning of life on Earth is suggestive of, I can sort of understand, appreciate why people do believe there is a designer, because it's so improbable. But the one thing I can say for sure is that the probability of finding intelligent life that's already here visiting us is even smaller, suppressed exponentially so.
Oh, thank you. That was wonderful. I know you have to run in a moment, but we didn't have time to talk about your second book, Into the Impossible. But I do want to give a plug for that.
Yeah.
And there's a quick question, if I may.
Yeah.
Is there a through line? There's a lot of advice in this book. Do you find there's say some connective tissue, or maybe something that you found was a common pattern across the advice of the Nobel Prize winners that you interviewed?
Yeah, excellent question. Definitely is. There's basically, they cleave into 2 different categories. There are those that are kind of have this preternatural confidence and bordering slightly on arrogance. If I look at Sheldon Glashow, who's the real life inspiration for young Sheldon and
right.
wonderkind, just incredible preternatural confidence. And then there are those like Barry Barish, who actually told me, shockingly, that he suffered from the imposter syndrome worse after he won the Nobel Prize than before it, because he didn't feel worthy of being in the same book as Albert Einstein. Actually, there literally is a book that when you win the Nobel Prize, you have to sign it to prove that you got your medal and your cash and whatnot, so you don't come back and demand it later, as some clever person once did, apparently. And he turned the pages and he saw Richard Feynman and Marie Curie, and then he saw Einstein. He said, I'm not worthy of being in Einstein's neighborhood, let alone the same book. I said, Barry, I have good news for you. Einstein had the imposter syndrome that you suffer from as well. He said, oh, you can't be. And I said, yeah, he believed Isaac Newton was the greatest human being, greatest contributor to all of civilization who ever lived. And I said, but that's not all. Isaac Newton had the imposter syndrome. And he's like, I can't believe that. And I said, no, he believed that he could never live up to his hero, Jesus Christ. So he tried to live up by doing the one thing he could do. He couldn't walk on water. He couldn't turn loaves into fishes. He couldn't turn water into wine, but he could die a virgin. And in fact, he did. So, his personality helped with that. So the common point is that you must have 2 traits to be a good scientist. You must have humility on one hand, and you must have ego and chutzpah, as we say in Yiddish, On the other hand, you have to have those, because if you think that, oh, I'm not good enough to do this, you'll never have the confidence to try to make a measurement of the collision of two 60 mass, 30 mass solar mass black holes. Okay, you'll just never do it. You'll never have the gumption, the kind of confidence it takes. But if you only have confidence and you're like, oh, I'm the best thing ever, you'll never have people to work with, collaborate with, and support you along your way to then achieve this, outsized accolade that's known as the Nobel Prize.
Gotcha. That's great. And a very quick one this Sunday. Actually, by the time this interview is out, most likely Oppenheimer will have won Best Picture. It's the odds-on favorite. Crazy odds to win. On a scale of 1 to 10, what's your review of Oppenheimer?
I really enjoyed it. I thought it was just way too short. It should have been 6 hours. No, I thought it was a little bit long. And I say that one of my best friends is Josh Peck, who is in the movie.
Oh, yeah.
And he plays, let me see, who does he play? I always forget the name. That's Josh Peck.
Yeah, Josh.
Kenneth Bainbridge. So I have to flex a little bit. Carlos, you'll permit me.
Go for it.
Josh Peck has 17 million followers on Instagram and elsewhere. And he wrote me an email, this is like 5 or 6 years ago. And he said, I love you. I love your work. I love your podcast. I'd love to have you on my podcast. And then I didn't hear from him for like 2 years. And then a couple of years later, he then surfaces and is like, Brian, I need your advice. I'm being cast to play a physicist and I'd love your advice. And I said, sure. And so he talked about what a physicist would be doing and how they would have acted in the Manhattan Project. And I said, what is this for? And he said, well, Christopher Nolan cast me in Oppenheimer and I'm going to play this guy, Bainbridge. I was like, oh my God, this is amazing. So just this coming Sunday, when you were mentioning the Oscars, so I'm going up to Los Angeles. I'm taking one of my kids up to see the Clippers take on the Milwaukee Bucks and lose to my favorite player, Giannis Antetokounmpo. I can never pronounce his last name.
He's amazing.
I love him.
He's incredible.
My son's, and he's like basically a genius. I mean, if you ever hear him talk, really? I would love to have him. I'm going to ask him if he'll come on the podcast if I get a chance to meet him. He's, he has the highest ratio product of height to IQ of any human being has ever lived. If you just, he was asked 2 years ago, he was interviewed by ESPN, and the guy was kind of a jerk and asking him, how do you feel? You've lost. Now it's 2 times in a row you've lost. And he's like, let me ask you, have you ever won the Pulitzer Prize? How do you feel? You lost it every year you've been a professional. Like, do you think that makes sense? Do you think that's the only thing that we do it for? No, I'm going to come back stronger and better. Anyway, that's I'll take. So I said after I go to the Clippers game, I wanted to take Josh out for dinner, just hang out, meet him, not do a podcast, but just he is going to come on my podcast to talk about Oppenheimer. But I said, let's just get together for dinner. He's like, oh, I'd really love to. I'd love to meet you and your son, but I have to go to the Oscars. So I was like, okay, that's fair enough. That's a bigger flex, sure. But just a wonderful guy. I loved it. I didn't feel there was enough physics in it, to be honest. So I made a video on my channel called The Physics of Oppenheimer, or Physics Professor Teaching Oppenheimer. It's got about 80, 90,000 views. It was super fun to make that up. I put on a hat. I tried to suck in my cheeks. I'm a little chubbier than Oppenheimer was, just Cillian Murphy. But I'm really hoping it'll win, just because if Barbie wins, my daughter's going to force me to go take her to see it. So
you should see Barbie. It's a cultural phenomenon.
I will. You know what I'm waiting for?
I have my reservations about it.
I'm going to Chile in a couple of weeks to work on the Simons Observatory for the 5th or 6th time. I would go down there a lot. And usually they have one of these popular movies out. I just refuse to pay for it, so hopefully it'll be on. I'll watch it. I'll take a picture of it and send it to my daughter, and she'll stop bugging me. But no, I do want to see it. So yeah. Yeah,
you got to see it. I can't believe we didn't talk about basketball. I'm a huge basketball nut.
Are you?
You mentioned in one of your books.
Amazing.
You mentioned in one of your books playing basketball, so I wanted to ask a bit about your game and what your style was, and kind of like how you would fit on a team.
Yeah, I used to play, outside at Brown with my advisor Peter Timby, and
nice.
And but yeah, no, and my best friend, from grad school and really my life was Stephon Alexander, who's a professor at Brown now.
The Jazz of Physics.
The Jazz of Physics, right? Yeah. Have you had him on?
Great book.
Have you had him on?
I've asked him, but I don't think I got through his first filter. But that was a while ago. I was much smaller then.
Yeah, he's got a new book, or not new, but it's 2 years old, called Fear of a Black Universe. So Stephon is the past president of the National Society of Black Physicists.
Yeah.
Just one of the biggest geniuses you'll ever meet. And he could talk about these theories of everything better than anybody because he's incredibly knowledgeable and he's impartial too. But Stephon's claim to fame is, I could beat him in basketball. So he gets beaten by a slow, white Jewish guy, and he never lives there. But he's much faster runner than I am. He can smoke.
Yeah.
As
Good to know. Well,
if you're ever in New York, okay.
Oh, thank you so much. Yeah, I'll put you in touch with Michael as well.
That'd be great.
We had that connection earlier. Thank you so much.
It's been a blast. Let's do it again next time. Thanks so much, Carlos. Have a great day.